So in this video we're going to find the radius of convergence for this power series here, which is quite a typical power series. We've got n equals 0 to infinity and the sum of all of these nth terms here, 2n factorial x raised to the power of n. Now you can see here, comparing to the standard setup of a power series, we've got n equals 0 to infinity. We've got a term here, a subscript n. Now this is just the nth coefficient of the power series. So in this case, we've got x minus c to the power of n, where c is some constant. Now our case here, we've got no minus or plus of any integer. So in this case, our c equals 0. So that's what we've got here. So then we're just left with x to the n. Now our nth coefficient, a subscript n, if we take x to the n out of it, what are we left inside here? Well, in this case, we've just got 2n factorial. So a n equals 2n factorial. Now that's our building blocks to get to our answer. Now next, what we need to know is what technique are we going to use to find that radius? Well, for this particular style of question, the ratio test is the way forward. So the ratio test, and what the ratio test is, we want to find the limit as n approaches infinity of the absolute value, and now we have a ratio, hence we've got a division sign here. Now we have a subscript n, so the nth term, and then we want to find the ratio with the next term up in the sequence, which is a n subscript plus 1. Then that will give us a value which we're going to call r. So what we'll do is, now let's have a go at this ratio test and then see what we get for our r, and then we'll analyse the answer and see what kind of radius of convergence that gives us. So an, well, an is 2 factorial, 2n factorial. We want an plus 1. So an plus 1, that's basically just add 1 to each of the n's. Well, in this case, we've only got one of them. So then that will be 2 times n plus 1 factorial. So in these kind of questions, what I would do is I would break this down and call that 2 times n plus 1 times n factorial. Because that's basically what that would be. It's n plus 1 times n factorial. Okay, let's plug it into the ratio test. So we want the limit as n approaches infinity, the absolute value, an plus 1. So let's put that term in the top. 2n plus 1 n factorial. So that's our numerator. And in our denominator, we just put the 2n factorial. Okay. So now what we need to do is do some simplification on this term here. So we've got 2 divided by 2, they can cancel out. And we've got n factorial. As these are all multiplied, we can also cancel those out. So now we're left with the limit as n approaches infinity, the absolute value of n plus 1. That's all we're left with there. So now as n approaches infinity, this will just approach infinity. So therefore, this will equal infinity. So that then becomes our r. That's our variable that we're looking for now. So we've got r. Now the radius of convergence will be the reciprocal of this r. So now what we want is 1 over r. So I'll just put ROC, radius of convergence. So now we're left with 1 over infinity. Now 1 over infinity is 0. So therefore our radius of convergence of this series here is now 0. So we'll just put that down as our answer. It's 0, our radius of convergence. So the radius of convergence, what is that? I've written on the bottom here, you may have seen that through the video, the radius of convergence is the maximum radius disk that the power series converges in. So in this case it converges only at 0. Any values above that it won't converge, it will diverge. Okay.